walking the same speed over a distance of time. So a graph is a diagram showing the relation between variable quantities, and why is it important to be able to interpret graphs?
Gives us a good way to interpret.
Exactly. Yeah. So if you don't know how to read a graph, then you're not going to understand what was happening or how to go from there. So it's important to understand each of the axes and what they mean and what the graph is actually showing. That's why it's really hard when you look at A, because I thought A was the right answer too. You look at it and you're like, oh, he starts out slow, he picks up his pace, and then he keeps it. Like, because that's the only one that really shows it being constant. But D is actually the right answer. So what would be an example of constant speed in real life? Like, where could we see that?
On the highway.
Okay, if you're going what?
When we see that,
If you're going to speed limit, yeah.
Like if you're not in cruise control and you're just going at constant speed
Exactly.
in a direction.
Yeah, good. Does anyone else have another example?
So code 2.
Joggers. Maybe jog along and they would have a pacing maybe.
Okay, yeah, that could be one. I was also thinking like a helicopter. If they're in like hover mode, so they're just standing there, the propellers are moving at the same speed the whole time. They're not going faster or going slower.
So all the words are exactly the same. The only thing that's different is the bottom part. And it says, Jody needs help figuring out what Jack was doing. Which of the following?
Okay, so who can explain how constant speed and time intervals, like how they go hand in hand
So
in the proof? So what happened in our experiment that would show constant speed and would also show time intervals?
In the beginning, it started off he was going slow, which would be
Sorry.
time interval. But as it hit, when he got faster, he did a constant speed, and I don't,
Yeah, that was good. It's important to understand that a time interval, if we didn't know that Jack was having the same time interval, they were dropping at the same pace, we wouldn't be able to determine his speed because he could have just been dropping them randomly. That's why when you were dropping the beans and you were like, oh, and you start dropping like multiple, that's why it was important to have steady time intervals so that you can see the actual speed in between each of the beans or each of the drops. Why does it appear that they become further apart? Like, why is there such a big jump between these beans or these drops of ice cream and when he speeds up?
because of his pace.
Because of his pace?
Saw a dog and started running at even pace to go see it.
Yeah, exactly.
I guess it could also be that like the ice cream's dripping at the same rate no matter what, but
Right.
he's just moving, he's like covering more like,
Distance.
yeah, and so they're gonna be more spread apart because he, what I'm saying.
So let's think about something else. Would you be able to tell the speed of that someone was walking if they had different time intervals? Why? Why not?
No idea.
You don't know? Does anyone know?
Well, in order to measure it, it has to be a consistent distance. Like when you're measuring inches, they're the same thing.
Right.
And so if you're measuring time, it has to be the same amount of time. And if it's not, then it's not. You can't use it to measure.
And when I messed up the beans and they like fell out of my hands, like you wouldn't be able to know how fast I was walking because they were like just random. They
Right.
weren't like set intervals.
Right. So now let's try and draw the beans on the ground. I'm gonna here. Does someone wanna count the tiles and how many tiles we use?
Yeah.
You want to? Okay. Because that'll give us our position.
Yeah. So if you look at this, it is a little tricky. I would say it
Yeah.
A and D. But the reason it's D is because Jack started out
And then does someone want to count which tile, where a bean lays on which tile?
spread out more on each graph.
31. How many? 31. Okay. Just like count like how many tiles. So like the first beam is on tile 1. So hold on, don't start yet. Don't start yet. I'll tell you when to tell me. Okay. Let's see. So we did it in 3-second intervals.
Someone else should have reads.
It was so hard. They were like sliding.
So we're going to break up into groups. We have a whiteboard, and we are.
So one drop that. Right, still.
This has to be very or maybe you should do like
Yeah, I'm gonna give you a pop.
Alright.
Okay.
Okay,
So
so there's
read it
one,
twice.
4. Okay,
This
wait.
is the problem.
So that'd be
And you accelerate for 10 seconds.
4.
Constant speed.
Yeah,
Stay at
so
this
start
speed
here,
for 10 seconds.
and then you go up.
And slow down
Okay.
for 5 seconds.
6.
Until you stop. Okay. So remember that X is the time and Y is the position.
11.
Position is also.
that makes
Yeah.
more sense.
Do you want to draw your drawings
15.
first so you can? Yeah. It might be easier. Then you can make it smoother. You can also do
20.
some measurements on the bottom of your time, like 5 increments.
Good enough. Alright.
27.
Alright, that's
One
good.
more time.
Alright, so we see that it
For
goes
10 seconds.
at a constant up,
Stay at this
and then after that it
Slow
was
down for 5 seconds until you stop.
essentially it would even out. It's hard to show.
So this is distance away and
Right.
that's how long it is.
Right, so essentially time's always going to be on the bottom because you think about it over time you're going a certain distance. What do you think would be difficult for students to understand about graphs?
Because I can't see the whole thing, maybe.
And what about like these graphs? Why did it make it so hard to read these graphs?
They weren't labeled.
They weren't labeled.
Because I thought A was the right answer because I thought that the x-axis was speed and that the y was space between drops. So like whenever he was increasing his speed, the drops were becoming like spaced out more. So I picked A. If it would have been labeled differently,
One
then
thing you could have done differently is I never really said about 2 minutes started, so we could have started all the way up here.
Good. So
Something like that.
if they were labeled, it would have been easier to understand, which is why a lot of students get graphs really mixed up.
Does anyone have a risk discussion?
Seeing a real example really helped me a lot.
Yeah.
To
Yeah.
understand what we were talking about.
Yeah, it's not an easy concept to understand.
Yeah, it's like position. This like, oh, distance away from us.
Exactly. So if you think about it, like this is the distance that he went. So if it was 18 tiles away, how fast was he going? You know, like at 18 seconds he was going a lot fast. He was walking a lot faster than he was walking at originally 3 seconds.
So this is showing the speed, how fast it's moving away.
Right. And a lot with Jack's graph, it's really important to notice, like, if you look at the dots, so everyone look at your dots, you see, like, 1, 2, 3, 4, at, like, between 3 and 4, it starts to become spread out. So then when you look at your graph, let's say you made 3 tick marks, you would see, like, oh, that's where the increase in the graph is. And then you go down, and it's like, oh, okay, well, now it's constant, and it's at a constant increase because you're getting further and further away, but he's staying at the same speed.
So it's a steady straight up angle instead of moving up or down.
Exactly.
So, can anyone explain
Can anyone explain
something new that you learned?
something new that you learned?
So straight equals a constant speed, not necessarily level.
Yeah.
Yeah, so the straight means that it's constant, the same amount of speed. Versus because I was wanting it to level out.
Yeah.
You know?
Yeah. And what did you learn about uniform motion, Courtney? Good job. All right.